Welcome back, everyone. We're jumping right in today because we are tackling a challenge that is literally keeping software architects and engineers up at night. We're talking about navigating the incredibly crowded, constantly shifting landscape of AI frameworks. In this explainer, we're going to break down Ajay Walia's definitive framework atlas for building with large language models in 2026. The goal here is simple. We want to demystify the complex architecture behind modern AI and hand you the structured mental model you actually need to build robust, scalable apps. And we are starting with an absolute bang. Look at this quote from the source. Choosing an LLM in 2026 is the least important decision in your stack. I love this because it completely flips conventional wisdom on its head. For the last few years, we've been absolutely obsessed with foundation models, right? Are we using GPT, Claude, Gemini? But as this landscape has matured, that choice has basically become commoditized. The real make-or-break decisions, those actually happen in the surrounding architecture. Okay, let's dive into this. Here's our roadmap for the explainer. First up, the model obsession trap. Then, mapping the canonical stack, navigating the abstraction trap, heuristics for framework selection, the rise of production agents, and finally, future-proofing through swappability. Let's get to it. Section 1. The illusion of choice. Section 2. Mapping the canonical stack, the shape of AI. So, as we just touched on, spending all your engineering energy agonizing over which foundation model to use is a massive trap. When architects focus entirely on the model, they end up with these silent failures in production. Think about it. You might have the smartest model in the world, but if your retrieval layer drops context, your app fails. And this brilliantly illustrates the fix, the canonical AI stack. Looking from the top down, a user request hits the application layer, moves down to the agent layer, pulls context from data and retrieval, touches the model layer, is served through inference, and all of it runs on base infrastructure. This right here is the mental scaffolding you need to hold in your head. Let's unpack those layers just a bit more. You've got your 6 core functional layers, but what I really want to draw your attention to are the 3 cross-cutting concerns wrapping around this entire stack: observability, fine-tuning, and guardrails. In 2026, these are non-negotiable. If your system design doesn't account for observability and evaluation, you are literally flying blind. And guardrails? That's your safety net. Prompt injection is the new SQL injection. These wrapping layers are the actual unsung heroes of production engineering. Ignoring them doesn't eliminate risk, it just defers it until something catastrophic breaks for your users. Section 3. Navigating the abstraction trap. Speed versus control. So how do we actually evaluate our tools? Well, every framework out there sits somewhere on a spectrum, but the single most consistently underweighted attribute by architects is the abstraction level. Simply put, this is a measure of how much code you write manually versus how much the framework is just deciding for you behind the scenes. And this creates a fascinating dynamic on engineering teams. Junior teams tend to overvalue high abstraction. Why? Because it makes that very first prototype incredibly fast to build. It's like magic. But the catch is, when something eventually breaks, you're stuck trying to debug someone else's hidden default decisions. Senior teams, on the other hand, overvalue low abstraction. Sure, it takes them longer to build the initial app, but because they wrote the explicit logic themselves, there are far fewer surprises at 3 a.m. when the system is under heavy load. The big takeaway? Make your abstraction choices explicitly based on your team's seniority, rather than just downloading whatever framework has the most stars on GitHub. Section 4. Heuristics for Framework Selection, the Practitioner's Guide. Now, what's really interesting about this is you don't have to choose everything in isolation. If you need a fast prototype, LangChain plus Chroma is great. For enterprise-grade RAG, LlamaIndex plus Weaviate. Crucially, LangChain and LlamaIndex are often viewed as competitors, but they really aren't. They actually compose cleanly together. For instance, you might use LangChain up at the top application layer to handle user chat, and then plug LlamaIndex into the retrieval layer because its indexing abstractions are honestly the best in the business. We can actually see these trade-offs visually right here in this orchestration radar chart. Look at how these frameworks stretch across the different axes. LangChain is incredibly broad, massive community support, huge extensibility. But then look over at DSP. It represents a totally different declarative approach to prompt optimization. It trades a bit of ease of use for massive performance and structured stability. Or take Haystack. It's heavy on infrastructure but incredibly mature for production NLP pipelines. You really have to pick the tool whose shape matches the specific problem you're trying to solve. Section 5. Rise of Production Agents, Moving Beyond Demos. So let's move forward and see how this builds. We are finally moving past those fragile Twitter demos.
Today, autonomous agents are powering critical production use cases. Think customer triage, intelligent routing, deep research synthesis. And every reliable agent operates on a fundamental state loop. First, it plans a task. Second, it acts by calling a tool. Third, it observes and captures the result. And fourth, it reflects and critiques its own output. This bounded observable loop is what makes autonomy actually safe to deploy in modern apps.
Because this loop is so absolutely critical, the frameworks have evolved to support it. So here is the first rapid-fire maxim for you to remember. For production agents, reach for LangGraph. It uses a deterministic state machine architecture. You explicitly declare your states, your transitions, your retry policies. When you need absolute control and inspectability in production, this is your gold standard. Next maxim. For multi-agent conversations, use AutoGen. When you're dealing with a complex task that requires different specialized agents, say a planner agent, a coder agent, and a critic agent working together, AutoGen's conversational protocols are just unparalleled. It models the entire system as a negotiation, which makes it incredibly expressive for complex critique and revise loops. And our final maxim. For lightweight workflows, choose Crew AI. It has this beautiful, simple mental model where you define agents as crews with very specific roles. Now, it might lack the super fine-grained control of LangGraph, but for mid-autonomy document pipelines or research synthesis, it allows teams to build highly effective systems really fast. Section 6. Future-proofing through swappability, the ultimate design invariant. All right, we've covered a ton of ground, from the underlying stack all the way to the latest in agent orchestration. So the crucial point is, how do we ensure our hard work doesn't just become obsolete in 6 months? Well, the answer is right here. Frameworks age faster than architectures. The single most important design invariant is swappability at each layer. That canonical shape we talked about earlier, application, agent retrieval, model, serving, that shape will survive, but the specific tools filling those boxes today, they are inevitably going to be replaced. Your job as an architect is to build clean, independent interfaces and keep that framework-specific code as thin as humanly possible. And that leads us to the final, provocative question I want to leave you with. In 3 years, when the frameworks you are writing code for today are completely obsolete, will your architecture survive the swap? By understanding the canonical stack, managing your abstraction levels, and building those clean interfaces, the answer can be a resounding yes. Thank you so much for joining me on this deep dive through the 2026 Framework Atlas. Keep building, keep learning, and I will see you in the next explainer.